So in this video, we're going to look at the implementation of the ring-fence cipher. We already spoken about the theory in the previous video. So we are going to need numpy, so let's import it as np. Then I also want to use the same example that we used in the video. So in the video, our key was as follows: 4312567, and our plain text was attack postponed until 2 a.m. So in this video, I just want to use a function. There's no special reason why I'm doing this. I guess it's just easier to work with. And the function will take a key, which is an int, and it will take some plain text, which is a string. And in this function, we want to start by preparing our variables. So you can say prepping variables, something like that. And we can start with the plain text. Ideally, we want to remove all the spaces in the plain text. And to do that, we can run this simple line where we replace every space that we see with that, just an empty string. Then in the next line, we want to form a list out of the integers in the key. So we're going to convert the key to a string, then convert each character in the string back to an int. I know it's a bit all over the place. If you find a better approach, then let me know, or just implement that. Then this is what we have. So this list contains all the numbers 4312567, and they are in integer form or number form. And next, we want to sort these, and this is for obvious reasons, because we want to follow the sequence of the sorted list. So we're not removing them as you saw them in the theory section. We're just creating another list which will help us to single out the columns, or at least get them in the correct sequence. So this list will now store the same but in a sorted format. To do that, we're going to create another list that is identical to the one before, and the reason is sort doesn't return a value. So ideally we just call this, then return it to sorted key list, but sort doesn't work that way. So in the next line, we are going to perform our sorting like that, and that just sorts the thing, or it changes the values in there, and they're now sorted after that line. The next, we want to fill in the gaps. So we saw that in our example, we were short of 3 letters. That's why we had XYZ in the end. And to do that, we can start all the way at the back. It's up to you. You can start at the front or at the back of the ASCII table to find filler text. In my case, I just want to go from the back. So from Z, remember that small letter Z has an ASCII number of 122, or 122 is associated with the small letter Z. So if we start at 123 and we subtract 1, we land exactly on Z. That's how we go from the back onwards. So that tells you that we should use 123 as our upper limit, just like we do when we convert the ASCII values into our letters. So we want to check if the plain text is divisible by the key. In this case, we're going to use the key list because it has the total number of numbers or characters in the key itself. So if that is greater than 0, so in other words, if the plain text is not divisible by the key list, then we want to append some letters starting from the end, right? So we can say we are appending letters starting from the end, so Z, backwards. And we want to make full rectangle. So the number of letters that need to be added, so that can be stored in a variable. So number of letters to add, so the length of the key list subtract this remainder. So I might as well just create a variable here. So let's call it remainder, and it would be the length of the plain text modulo the length of the key list. So if the remainder is greater than 0, then we're going to do this, and we want to subtract that remainder to find the number of letters that need to be added. So for I in the range, starting from the back, so from Z minus the number of letters that need to be added all the way to the end at Z, which is 122. Remember, this is not inclusive. Then we are going to add to the plain text as follows. So we're going to convert each to characters and add it to the plain text. So as I gave an example, if the number of letters to be added is 1, as an example, so our example says that the number of letters to add is 1, then 123 minus 1 would be 122, and an ASCII value of 122 corresponds to the value or the character Z. So here we'll just add character 122, which is Z. In this specific case, the remainder is 3. So now subtracting that will allow us to add 120, 121, and 122, which correspond to X, Y, Z. And those are the ones that will be added to the plain text so that the plain text can form a complete rectangle according to our theory. So that's what we want, and this is how this works. Calculates the remainder, and it uses that to add on to this, to the plain text. So it doesn't have to be from the back, it can be from the start. You can change the logic as you see fit here, because there isn't a set of letters which you're supposed to use. You can use any letters to fill the rectangle up as long as you remember them. Alright, so next, after preparing our variables, our key is sorted and our plain text has been added up to form a full rectangle when we start the encryption process. So in this video, I'll only cover encryption, and I'll leave decryption to you as homework. So encryption, we want to have a clear number of the columns that we have, and that comes from the list. Remember, we're forming an L times W rectangle, where L is the length of the key and W will be the plain text divided by the key, or the columns in other words. So our rows would be the length of the plain text, and we want to have integer division, and that's why we're using both of those, divided by the columns. Then once we have this, we can start our encryption process, and to do that we need our encryption rectangle, and you can either do it all at once like I will now, or split it up a bit. It's totally up to you. So encryption rectangle would be the NumPy array that is formed from all the letters that are in the plain text, and we're going to reshape this according to the dimensions which we just calculated now. So that would be rows times columns. So in our case, we have the length of the key, or the key list, is 7, just like we discussed in the theory, and the plain text length, actually we can check both of these so that it's much clearer. So let's print the key length, which would be the length of key list, or we can just use rows and columns in this case because we already calculated that. So let's just have calls there, and here we can have, let's just print the length of the plain text length, then that would be the length of our plain text, and down here we can have the number of rows that we're going to have in our rectangle. So this would be the columns as well, so might as well add it there, and here we can have rows. So let's quickly print this, and we need to call our function. So down here you can call the function so that it executes, and you can pass in the key and our plain text. Okay, so if I run this Python and then the name of our script then this gives me the following. So I have the number of columns as 7, or the key length as 7, and the plain text as 28, just like we had in the theory section. And if you divide those, we get rows equal to 4, or in other words, each column has 4 letters because the rows go horizontally, and that also represents the number of elements in a column, right? So our math works out, and that's exactly what we want. So our rectangle will be rows by columns, just as we have it here, and we are good to go. So just remove this so that we continue with the encryption process. So this is our rectangle, and we can also print it out just to see what it looks like. So encryption rectangle looks like this. Let me run the script again, and that's what it looks like, and that to me matches our theory section. Okay, so we're good to go, and we can continue. You can see the XYZ there at the end, and the next step will be picking out the columns based on the keys values, and that's quite easy to do, at least with NumPy. So we have ciphertext, which is the final result which you expect to get. It's currently empty because we haven't started the encryption process. Then we have for number, in now we're going to use our sorted list because it has the numbers 1 to 7 and they're in the correct order. And here's how we're going to link this to our key. So now we want to use this column index. So we want to fetch where the first key is, or where 1 is in the original key list, and we're going to use the function index to find that. So here's what this looks like. Our sorted list has 1, 2, and so on, but our original key list only has the key as it is up here, which is 4312, 4312, and so on. So now we are fetching the index of 1 in this list based on where we are now. So here we're following the correct sequence, which is 1, 2, and so on, but that's not how it's laid out here. So we have to find the correct index, and that would allow us to then go to the encryption rectangle and pick that based on where it is. So these are fixed. If you imagine these above the encryption rectangle, these are fixed. So the index of 1, remembering that we started an index of 0, would be 0, 1, 2. So the index of 1 is 2, and this helps us to find that. So using an index of 2 and coming back to encryption rectangle, we're going to go to column 2, or the column that matches index 2, and fetch that, because we have to start where we have the smallest number, in our case, which is 1. So that's a column which you have to start at as we encrypt, and this helps us to find the correct index of the numbers in the correct order. So if we just use this as in index 0, then it would fetch the wrong column in the encryption rectangle. But these two combined help us to find the correct index in the encryption rectangle. I hope that makes sense. So now we're going to come back to encryption rectangle, and our ciphertext would be formed from us joining an empty string to the column that we're going to fetch from the encryption rectangle. So in the encryption rectangle, we're going to fetch this column. So we don't care what happens to the rows. We want to focus on the column index, which is just found. And in the first example, I'm just going to now print the encryption rectangle again, so I can quickly explain what we just talked about. And let me just comment this out. Well, I don't have to, because I'm not printing the ciphertext anyway. So this is our encryption rectangle, and we just found an index of 2 according to the example which I gave you, and that would be 0, 1, 2. So this here, TTNA, is the column that has an index of 2, and we found that by finding the correct index in the key that matches the current key that we're key letter that we're on. So 1 will come first, but its index in the original key list is actually 2. That's where we're going to start. So we're going to take TTNA first, and this line allows us to take the whole column. And after doing that, we convert it into a string, which is added to the empty ciphertext at this point. And we're going to continue like that, finding the correct index of the column and fetching the whole column until we have the ciphertext that we want to have. And so to do that, I can take that print statement out, but down here, I can return my ciphertext instead of just printing it. And if I return it, then here I can have another variable, ciphertext output or something like that. Or I can even call it ciphertext because this is outside the scope of the function and it wouldn't affect that one. But let's call it ciphertext output for now. So this is a function call which will execute everything in the function and return our result. So if I now print the ciphertext, or I can just focus on everything. So we have a key of key and plain text. So I'm going to print this actually. So I might as well just have an F string there as well. And that would be my plain text. And finally, I'm going to have this ciphertext output, which I just calculated. And let's see what this gives us. So I'm going to run the script again. And the result is key 4312567. Plain text is that, and this is our ciphertext. And that to me looks exactly like what we got in the theory section. So just as a quick recap, I decided to make this function just a function just because. There's no specific reason for that. You can skip this and just have it outside and then print here instead of returning. That's totally up to you. And we started off by storing the key values or the key numbers in a list. Then we sorted that list so that we can have the correct order for fetching the columns. After that, I filled up my plain text such that it forms a complete rectangle as we want to have. And the dimensions of the rectangle are calculated as follows, as described in the theory section. Then we formed our encryption rectangle. From that encryption rectangle, together with the correct sequence of numbers or the correct order that we're supposed to fetch in, we then fetched the columns, and each column was added to the empty ciphertext, and that's what we return from our function. As I said, I'm leaving the decryption to you guys, and use this or any other information that you have to complete that. But this is all that we plan to cover in this video, and I hope you enjoyed the cryptography series, because this is the final video, at least for now. And share, like, subscribe, leave your comments. I'll see you in the next video.